Hi everyone, today we're going to be learning about seismogenic zones. So what exactly is a seismogenic zone? The term seismogenic means capable of generating earthquakes. So the seismogenic zone covers the range of depths within the crust or lithosphere in which most earthquakes occurs. The easiest way to understand the seismogenic zone is through the study of subduction thrust faults. As you know, subduction thrust faults is where a denser crust, such as the oceanic crust, subducts below a more buoyant crust, such as the continental crust. Subduction thrust faults generate earthquakes over a limited depth range. They are aseismic in their seaward updip portions and landward downdip. Therefore, the seismogenic zone is limited by the upper aseismic zone and the lower aseismic limit. The downlip limit is important for seismic hazards because it determines the landward limit of the seismic source zone, while the seaward updip limit is important for tsunami generation. Defining the upper limit. The seaward shallow aseismic zone, commonly believed accreted sediments, may be a consequence of unconsolidated sediments, especially stable sliding smectite clays. As these clays become dehydrated, they transit to become a stickier clay such as illite. Through this graph, we can see that the fault will become seismogenic when the temperature reaches around 100 to 150 degrees Celsius, that is around the 5 to 15 km depth. Next, we can define the thermal downdip limit. For subduction of young hot oceanic lithosphere beneath large accretionary sediment prism and beneath continental crust, the transition to aseismic stable sliding is temperature controlled. This is the depth where the rock starts to behave plastically and will transit from a velocity weakening, seismic, to a velocity strengthening phase, which consists of stable sliding. Laboratory measurements on quartzo-feldspathic crustal rocks have indicated that the critical temperature is around 350 degrees Celsius, regardless of the presence of water. For subduction beneath thin island arc crust and beneath continental crust in some areas, the fault mantle is reached by a thrust shallower than 350 degrees temperature. The fault upper mantle probably is aseismic because of stable sliding serpentine hydrated by water from the under-thrusting oceanic crust and sediments. In this subduction zone, relatively old oceanic crust is being subducted and there is no insulating sediments on the incoming plate. If 150 degrees of the upper limit is reached at a distance of 30 km and mantle dipiers are seen 40 km from the trench, there is only at most a 10 km wide seismogenic zone. Some island arc subduction zones also appear to exhibit a second deeper concentration of mainly smaller thrust earthquakes at a depth of 40 to 50 kilometers. One possible explanation is that the serpentite and other hydrated minerals responsible for aseismic zones between depths of 20 to 40 kilometers are dehydrated by the higher temperatures at greater depth, therefore allowing thrust earthquakes to occur again. It has been shown that the dehydration of serpentite will have to be preceded by 550 degrees, and the subduction thrust may be seismic from this point to a point of stable sliding or plastic flow, which occurs for mantle rocks at temperatures greater at 750 degrees. The idea of thermally limiting the seismogenic zone can also be applied to other types of faults. For a continental strike-slip boundary, studies have shown and compared that the deepest earthquakes occurs around 20 km, and they concluded that a critical temperature of 300 to 400 degrees Celsius is associated with seismicity cutoff. At oceanic divergent boundaries, seismicity is restricted to depths where the temperature is less than 600 degrees Celsius, indicating that a transition from unstable to stable sliding occurs with an increase in temperature above 600 degrees Celsius. This also coincides with the deeper friction stability transition for olivine that can be found in mantle crust. In conclusion, the seismogenic zone is where most earthquakes occurs, which is correlated to velocity weakening. Temperature plays a large role in the lower limit of seismic activity, while upper limit is more affected by the composition of sediments as shown by subduction thrust faults.